New vocabulary term right off the bat. In a circle, you can draw a bunch of angles inside a circle. A bunch of different angles inside a circle. First one I want to talk about what's called a central angle inside the circle. All right. This is circle O up here. Circle O. If I call it circle O, what do you automatically know from yesterday? 12?
O is the center.
O is the center. This is a central angle because the vertex, AOB, is a central angle. Everyone see where the vertex is? It's also the what? Center. So a central angle is an angle where the vertex is the center. So an example here, angle AOB. That is called a central angle because the vertex, and if you guys don't know what I mean by vertex, that's where the two sides of the angle meet, at the vertex. Okay? The vertex is the center for a central angle. All right? I talked about this very briefly yesterday, but let's get more in depth now. An arc, that's part of the circle. All right, part of the circle. How do you read that? How do you read that?
Line AB.
Line? Line segment AB. How do you read that? Line AB, little challenge. Ray AB. Arc AB now. Arc AB. All you're going to see is a little arc symbol like that. And the letters underneath. Now, question right away comes, which arc AB? Are you going AB this way? Or are you going this way? AB. I want to go right from A to B, no letters in between. If I wanted this arc right here, you know what I would call it? Arc A, CB. Notice the difference between those two arcs. Arc AB is go right directly from A to B now. If I want you to do another point in between, I'll put the point in between, in this case C. ACB. See the difference there? All good? Okay. First theorem of the unit. First theorem, first fact. This will go in your proofs eventually whenever we get to them next week. The measure of a central angle How many degrees in a circle? Anybody know that fact? 360. Yep. And we can measure an arc in degrees. So we could say, hey, arc AB is 60 degrees. Could be 80 degrees, 100, who knows? But we can measure an arc in degrees. How many degrees out of 360 it is? The measure of that arc is the same as the measure of the central angle. So if the central angle is 80 degrees, the arc also measures 80 degrees. That's the first theorem I'm showing you. The measure of the central angle is equal to the measure of its arc. And make sure you make a note when we say measure of the arc in degrees. All right, in degrees. So whatever the central angle is, it's the same exact degree measure as the arc that it belongs to. Questions? We measure arcs in degrees here, in degrees. All right, 3 special types of arcs I just want to briefly go over before we hit up some examples here. How many degrees in a circle again? 360. So I have this arc called a semicircle. Semicircle. So how many degrees do you think are in a semicircle? 180 degrees, yes. It's a half circle. 180 degrees. Anything bigger than 180, we call a major arc. Major arc, that's anything bigger than 180. Anything smaller than 180, we call a minor arc. All right, so 3 arcs to pay attention to there. You got your semicircle, which is half one, and then anything greater than that is a major, anything smaller is a minor. All right, I have 3 examples down here. First one, I'm going to ask somebody, name properly a semicircle. So arc blank is a semicircle. Name an arc that's a semicircle here. Whenever you're ready. 4, not here. 2, Matt, name a semicircle when you're ready. Arc TS, that's fine with me. And I know what arc Matt's talking about because I'm going right from T to S. If he talked about the other one, it would be called TRS. Good. Name a major arc on the second diagram. Blank is a major arc. Name a major arc, which would be something bigger than a semicircle. Name a major arc with the correct letters. 7.
RTS.
Yep, RTS works for me. STR, RST would be a major arc. That's a good one. And again, I'm going to keep making sure we know what Avery's talking about. This one right here, R to T to S. Follow the letters. That's the arc she's talking about. And then the final one here, name a minor arc in this last diagram. What's a minor arc here? When you're ready. 24, Mahmood, when you're ready. RS, fine with me. We could have went TR as well. Anything? Major, minor, semi. Because now I want to use this theorem I just showed you now. I want to use this theorem that the central angle and the arc is always equal. So let's do it. Do that later. All right, circle C. What are you telling me? This is a broken record, but it doesn't bother me. 9, circle C. So what do I know? C's the center. That's huge because now I have 1, 2, 3, 4 central angles, right? 4 central angles there because the vertex is the center. So I'm looking for first, what's the measure of arc AE? How many degrees does arc AE contain? Well, let me ask you a couple questions before I get to that. 15, what is the measure of ACE? Angle ACE, how many degrees? 90, because it's right next to another right angle. So that's 90. So if the central angle is 90, arc AE would also 20 be 90 degrees. Everyone see how I'm applying that theorem? Central angle equal to its arc measure. What about arc ED? How many degrees in arc ED now? 21, thoughts? 50, good, 50. 130 is supplementary to 50, so there you go, good work. All right, follow your letters. Follow your letters. Arc D to B to A. D to B to A. Follow your letters. How many degrees in that one? 10? 210 degrees. D to B to A. Good, because you're adding 130 and the 90. And the next 3 are on you guys. Go ahead. Or in your group. 220. Sorry, thank you. One job. 220. Next 3 of them are on you. Go ahead. Quick, good. All right, so let's talk. Be sure it's recording. Yep. All right, how about AED? AED, everybody? Let's hear 11. AED? 140, good. Arc ABD? 10? 220. Everyone notice that DBA and number 3 and ABD are the same arcs, just named differently. And then finally, arc BD, number 6. The 17? Buck 30. Good. Are we all right now? Central angle equal to its arc measure every time. A little bit different here on this next one, right? Because I didn't give you the degree measure. I gave you the percent, though. So give me the arc measure of AB. AB. I don't know the degree measure. I know the percent, though. So ready? This is 20% of the whole thing. Let me say it one more time. That's 20% of the whole thing. Anybody want to substitute in a degree measure for the whole thing? 20% of what? 360, right? This is 20% of the whole circle, which is 360. How you guys, little percent days. How do you find 20% of 360? 360 times 0.2, 2/10 times 2/10, however you're doing it. Yes. I obviously don't want to go 360 times 20 because that'd be a little bit bigger number than 360. So that arc will measure 70, is that 72 degrees? And now let's do it for arc CD. What's the degree measure in arc CD? So 360 times 0.18. $64.8 degrees. Looking good. Any issues? That right there is the first half of today's notes. How to find the measure of an arc. Now what I want to do, how long is it now? 2 inches, 3.1 centimeters. How long is it? We know what the measure is in degrees, how to find that. But now, how long is this darn thing? All right. If I cut it out, stretched it out, popped a ruler underneath, how long are these arcs? How long are they? All right. Don't confuse this with what we just did. We just found the measure, which is in degrees. Now we're going to find the length. Okay? Two separate things. Measure and length. All good? All right. This is our second formula in the unit I'm about to give you. They're starting to pile up. Circumference already yesterday. Now how to find the length of an arc. You first find the measure. It's what we did the first half of class today. You find the measure of the arc and put it over 360. How many degrees are in a circle? There's more, though. There's more. And then you'll multiply that by, this should look pretty familiar, pi d. Where's that come from? What's pi d again? Circumference. So and I don't know if this is processing with you. Basically, you're taking a fraction of the circumference to find how long the arc length is. All right, you're taking a fraction of the circumference and telling me how big that is. So there's your length of an arc formula. The measure of the arc over 360 times pi d. All right, ready? Get some space here. All right, what's the length of each arc? Oh, leave your answer in terms of pi, so everyone should have pi in their answer when I circle it or box it in. How long is arc AB? Not what the measure is, how long is arc AB in terms of pi? All right, so let's plug it into the formula. What is the measure of AB? What we worked on today already. Measure of AB, 22. Measure of arc AB. How many degrees are in arc AB? 90 because it's equal to its central angle. 90 over 360 times circumference. Pi. What's my diameter in this problem? Oh, 21? 24. That gives you the diameter already. All right, let me help you with the algebra here, or the calculation. It's got to be in terms of pi, so you better just put the pi in the answer now. All right, put the pi in the answer now. So what am I in charge of doing? 90 over 360 times Pi's already there. I'm not calculating pi here. 90 over 360 times 24. That's what I'm in charge of right now. Because pi has already been moved to the answer. I don't want to use the pi button for a second time. All right, leave the pi in your answer. So 90 over 360 times 24. And you end up with 3. 6 pi, and then everyone remember your good old units, inches, 6 pi inches. That's in terms of pi. Leave pi in your answer. Everyone's all good? All right, read carefully. I'm now looking for arc CDE. CDE, how big, how long? What's the length of CDE? All right, be careful when you answer this question. What is the measure of CDE? What is the measure of CDE? Oh, 14. I wish we had one. 6, measure of CDE.
320.
360 minus the 40 I was given. Perfect. Good job, Lauren. 320 over 360. Times circumference. What's the diameter in this one? 23 diameter. 18, and then pi. Pi d. Leave the pi in your answer. So 320 over 360 times 18. And what are we looking for on that one? 5. What do you get? What do we end up with?
7.15. Wait, no, I think I did the thing.
320 over 360, and then multiplied it by 18.
Oh yeah, 16 pi.
16 pi centimeters. All right. Any issues there? Calculating the length. All right, one more. F to G to H. F, G, H. What's the length of that arc? All right. Can somebody help me? What's the measure of the arc first for the formula? Measure of the arc. 22. Good. 90 and 45. 135 over 360 times diameter. 21 diameter length. 6. Bring the pi down and go to work. It's okay if you get a decimal here. You can leave it as that decimal or leave it as a fraction. Your call. $14, yep. 22 when you're ready.
9/4 pi.
Yep, 9/4 pi, or if anybody left 2.25, good job. Meters. All right, last thing I want to do with you, combine yesterday and today into one problem, which is the last problem. And I am not going to do a darn thing with you. I want to actually converse in your groups. I don't want to do a darn thing here. The only thing I'm going to say is you're looking for the circumference. Pi times d. What's the only, hey, well, before you start, what's the only value you need for circumference? What's the only value I need to plug in? All right, how are you going to find it? All right, that's on you and your group now. How do I find the diameter given the length already? You already know the length is 6.09, and you have a darn formula for it now. Go to work. Go to work. Come on now. Let's go. Go to work. To the place. All right, let's do this. I need to find diameter. What is 6.09? What is 6.09 in this problem? 5, what is 6.09? Not the measure. I'm not going to...
Can I just tell you the formula?
No, not the measure. Use the correct term. Because measure is in degrees. This is not in degrees. This is the length. Length of the arc. Have I given you a formula today how to find length of an arc? Yes? No? So that 6.09 is equal to that formula we used during the second half of today, which says what? Length of an arc is equal to measure. What's the measure of the arc? That's given to you. 6. What's the measure? 50 over 360 times circumference, pi d. And guess what we're going to solve for now? D. Now the question is, what are your algebra skills like to solve for d? But everyone all right with my equation I have up there? Length of an arc equals measure over 360 times circumference. First question, how do I get this out of there? Because I got to move this to the other side to get d by itself. So how do I move the 50 over 360 out of there? Whew. Suggestion? 14, yep, you got a good suggestion. 19, how can I get it out of there? I can divide it. I can do this. 50 over 360. Divide the other side by 50 over 360. We have fraction templates on our calculator. Did anybody do multiplication instead to get rid of it? What could I have multiplied both sides by to get rid of it? Times. If you didn't want to divide, we could multiply by something to get rid of it. Jonah?
360 over 50.
The reciprocal. So multiply both sides by 360 over 50, 360 over 50, if you want to get rid of it. All right, here we go. Pi d equals, I'll go even to my calculator with you. Alpha y equals 6.09 on top. You can still do another fraction template on the bottom and do 50 over 360. That's, here we go. There we go. 43.848. And then what do I still need to do to get diameter by itself? I need the diameter for circumference. What do I need to do still? 15.
Divide both sides by pi.
Okay, and I showed everyone where the pi button was. I'm surprised no one's calling me out yet, but we'll talk about that at the end, why you could call me out at this point in the problem. But so divide both sides by pi. And there's my diameter. There's my diameter. Plug it back in the circumference formula, and I think some of you are going to see what the heck I was talking about a few seconds ago where you could have called me out. $13 point. Okay, I'm going to cheat. There you go. That's how I roll. And what did you guys get back out? 43.848. Yes, Charlotte?
Oh, I was just gonna say.
Hold the thought. Hold the thought. So final answer here. Final answer. 43, because we had to round to the nearest 10. 43.8. Right? 43.8 inches for the circumference. Go ahead, Charlotte. Drop some knowledge.
We didn't have to do the last step because, like, the equation to find, that's the equation. So that's circumference equals pi times.
What's pi d, guys? What's pi d another name for? Pi d is another name for? There it is. That's what it's equal to. You already had that. But even if you didn't see it, that's fine. But yeah, that's how we got back there. All right. Okay. Let's go. Let's get going. There is one thing I wanted to tell you. I know there's a common question that came up when kids started their homework second period today, and I just want to make sure you guys are clear. First question today. deals with arc GCF, just so we're all in agreement here. GCF. Okay, GCF is that arc right there. I'll leave that up on the board for you. All right, get moving. Get moving. Let's go. We're not going to waste any minutes.